half for lunch and the other half for roast.
You would like to use something that don't necessarily contain the same amount of urgency that I mean, how fast does your hair will grow? Weeks later, 7 weeks later.
Well, then I get you.
Well said. Give you a little intro. Yeah, I'll just introduce it. Yeah. Just take it away after that.
I'm just saying, she just texted us. Okay.
All right, thank you all for coming out. Today we have Dr. Stephen Greybush giving this week's weather briefing. I think we're week 4 of the briefings now, and week 7 of the semester, so almost at spring break, but getting into the thick of it a little bit. Dr. Greybush does work on data assimilation, numerical weather prediction, Mars. He was involved with a field campaign recently that he's going to talk about a little bit today. Not too much winter weather here, I guess, over the next week once again, but at least there's a storm to talk about up over the upper Midwest. So Dr. Greybush, whenever you're ready.
All right, thanks so much for the invitation, and great to be here for the Ken Reeves Memorial Weather Briefing. And like Christian said, I'll start out with a little bit of taste of the winter weather field campaign called NASA Impacts. So NASA, you might think of astronauts and going to the moon and Mars, but NASA in addition has a big earth science component. And a lot of weather satellites to study the weather and climate are launched by NASA. And why would they do field work? Well, they want to see what is actually being sampled from space by flying into it and measuring it from the ground. Okay, so one big field campaign that we've done recently is the NASA Impacts field campaign. And this is specifically targeting Atlantic coast threatening snowstorms. The past few years, we got some good data sets, but you can imagine over the last month, sadly, we're missing some of those winter storms and have had to fly over Canada and the Midwest and other places to do that sampling. So this field campaign has 2 airplanes flying into the clouds. One of them, the ER2, based off of the U2, is actually flying up at 60,000 feet above the clouds. Okay? And they have radars pointing down, looking through the precipitation. And then secondly, we have the P3, think Hurricane Hunter, flying through the clouds, sampling actually what you're seeing in terms of snow and microphysics in the clouds. So I'll share some pictures from NASA. This is the ER2 down in Dobbins Air Force Base in Georgia. And you can see the pilot over here actually has a pressure suit because at 60,000 feet, you need that. And the ER2 has these really long wings. It actually needs to have relatively calm wind conditions at Dobbins for it to be able to take off. So the unfortunate thing for many storms is just as, let's say, the cold front's moving through Dobbins, that's when the interesting weather's happening, and we have to wait until the winds die down because it can't handle crosswinds. So there's going to be a lot of forecasting that goes along kind of with this field campaign, which I'll share in a little bit. And you can see kind of the view over there of what it looks like way above the clouds at 60,000 feet from the pilot's point of view. Second aircraft here, this is the P3. Okay, this is a taking off here at Wallops down near the Chincoteague Island. If those of you that might have heard of Ocean City, Maryland, it's about a half-hour south. Has wild horses running on the island, also a big NASA facility and hangar. And that's where the main field campaign is based. And I spent a week earlier in February down participating in that. Okay, so some of the scientists, like pictured here, are on board the aircraft. They can drop dropsondes to sample just like you would with a Hurricane Hunter. But they also have a lot of in situ probes. So all along the wing of the aircraft here, you have various probes looking at cloud microphysics, like this beautiful image of a snowflake here that you can see. And so as they fly into different levels of the storms, they're sampling different microphysical habitats to get a sense of snow formation and from the in situ perspective. So there's a lot of flight planning that needs to be done. And so here's an example of the forecast discussion down at Wallops. You can see me here in the middle. I was one of the mission scientists. Here's Lynn McMurdy. She was the lead PI of the whole field campaign. And they're looking out over, let's say, the next 5 days or so and need to plan how the flights work. So there needs to be a down day of rest for the pilots somewhere in that week. You have to try to plan it when there's less interesting weather. And then you're planning out kind of maybe the next flight and the next flight a few days later. Where will that flight need to go? Right? Will the takeoff and landing conditions be accessible or not? And then where's the interesting weather? Right? Because we're not just flying to just anywhere. We want to sample, ideally, East Coast winter storms. But if that's not possible, then winter storms elsewhere. Then we can get some good data sets for other scientists. So here's an example of kind of looking at a flight planning. So we look at both the ensemble mean, where a low might be, as well as kind of the uncertainty in the low prediction. So we do use some ensembles for that. And some of these decisions, one of them has to be about 3 days out. What's the general area we want to sample? And then as we get to 1 or 2 days out, we need to pick a particular flight plan because all this needs to be arranged with air traffic control and things like that. And then right before and during the flight, we can make small scale adjustments to the path. And so you are relying on forecasts at some greater lead times, but then can adjust a little bit as you get closer to the event. And we also ran a Penn State ensemble of WRF simulations using the ensemble Kalman filter here at Penn State as a demonstration of kind of getting some of that uncertainty to hopefully be something to think about when making some of these decisions as well. So here's an example for a storm in the upper Midwest. You can see this is a postage stamp plot. So each of these is a different potential realization of the atmosphere. Right? Some of them have really good snow bands over upper peninsula of Michigan, which is what happened. Right? Other of these show that there was not snow here. So this is a pretty large lead time. This might be the uncertainty you're dealing with 3 days out. But as you get closer, hopefully all the ensembles start to converge on something that you can take action on. Right? But even in the face of uncertainty, you still have to be planning your flights because that process needs to begin early. So here's an example of a flight that I was part of the planning for. Okay? So during the week I was down in early February. It was not an East Coast winter storm, so instead we had to target an Alberta clipper. And here's that clipper kind of over upper peninsula of Michigan. And in this case, a lot of the snow action was along the warm front, extending across southern Ontario and into Quebec. Okay? So our plan at 3 days out was to sample this area. We made a wide area because we weren't quite sure how fast this clipper would be moving. We want to make sure that would be somewhere in this box. And then about 1 or 2 days out, it was actually pretty well forecast to have a decent, moderate snow band over just north of Montreal. And the tricky part is we didn't want to fly right over Montreal. That would be a nightmare with air traffic control, so we went a little further west and tried to sample this band. So then here during the mission, okay, you have a room where you have forecasters, including students. So one Penn State student was down at one point right here. Okay, that's Eric. And then we also have mission scientists and those that are actually communicating with the pilots. Okay, so this is during the middle of the mission. The plane is up in the air. All right, one of our scientists from Stony Brook was actually on the flight at the time, sitting up front with the pilots. Okay, whereas the rest of us are watching this mission tool suite, seeing where the plane is flying and making adjustments. We saw that the band was starting to fizzle out to where the later legs of the band, so we then communicate kind of with our pilot communicator here, a former pilot. He picks up the phone, talks to the pilot in the pressure suit at 60,000 feet, and they make adjustments. So what does this look like? Here's an example of kind of this flight going through the snow band here. Here's one of the moderate snow bands that we flew through. We were telling which levels because you start out sampling pretty high, maybe 15,000 feet, and work your way down to about the lowest you can safely fly, maybe 6,000 feet or so. And each is a very different ice microphysical habitat to sample. There's actually an additional light snow band up here, but you have to be aware that the Canadian radar actually has a gap there. Right? So being aware of that, so it's okay to continue flying up through here, but this was the main thing we wanted to sample right in here. Okay, so these are two of the radars pointing down from ER2. And both these flights are kind of doing a ballet. The higher flying plane needs to go faster. Okay? So they're both trying to pass over the same middle point right in the middle of the band. And some interesting things with the warm front, we usually think of maybe a more diffuse, spread out temperature gradient. But here there's actually 3 degrees Celsius change right along that flight path in that short distance, 5 degrees Celsius right along there. So I thought that was pretty interesting that there's actually a pretty abrupt temperature gradient through that band. We've got some good particle images through there as well. Okay. So it's kind of giving that broader perspective. Here's that change in temperature. As you're passing through the band, you see the temperature rising as you go from the cold sector up here to the warm sector. And here's some samples of the precipitation. right, about 15,000 feet in height. You can see moderate to light to moderate snow here, and getting a sense for that from several different array of products aloft. So you can see winter weather is one of my interests. So as we look now to today's weather, we'll be seeing where is the winter weather. Is it any around here in the future, or do we need to look elsewhere? Okay, so we'll start out today looking at current conditions. So here in State College, it's just over 50 degrees, so pretty mild for a late February day. And the breeze has kicked up now that we're into the early morning. Winds 17 miles an hour or so out of the west-southwest. Dew points up in the low 30s. And kind of looking around the region right now, we'll get the latest conditions. Right, mostly 40s and 50s in Pennsylvania. And you can see those west to west-southwest winds blowing through here. Right, so starting out pretty mild. You can get a sense next for the frontal analysis for the entire continental United States. Here's the latest surface analysis. So you can see we're on the warm side of a cold front that is stretched across part of northwest Pennsylvania, western New York, and through Ohio. And we do see next weather systems are more, other than this small low associated with this cold front, out over the Midwest. Next, we can take a look at our satellite image. Okay, so we saw kind of where we have a low pressure located up here. See a broad area of cloud cover kind of all along the frontal boundary. So this is our IR satellite. We're seeing these are high clouds kind of extending across the middle part of the country out toward Texas. Here you can see these cold clouds. These are not necessarily clouds, but perhaps cold surface conditions up over Canada and other areas of high cloudiness out over the Pacific Northwest. So if you're asking where to go for winter, the western United States has been seeing a lot of cold, and this upper Midwest and the western United States is the area perhaps if you wanted to experience the most winter weather in the next few days. So comparing our surface analysis now to kind of lows and winds, it's the windy.com site, you can see kind of the surface winds here. Here's that frontal boundary. You can see through this kink in the isotherms and this trough of low pressure. There's an area of high pressure up over near Hudson's Bay, James Bay right here, and the next low, surface low, found out over kind of the North Dakota, South Dakota, Minnesota border. So let's get a sense for the upper air pattern as well. Okay, so going up, this is a view of the North Pole, right in the center of this map. This is the jet stream extending around the pole. Okay. So this is a sense of where our jet's located. We come down here, right? This active part of the jet is right over the location where we saw a lot of the clouds in the infrared image. Right here, you see this big meander of the jet. This is actually a big cutoff low off of Baja California. We see a big ridge over the Central Pacific here. And we'll kind of watch and see how this pattern evolves over the next few days. And so now let's step out in time a bit and get a sense of what's going on for our area, as well as the CONUS. So this is kind of following our 6Z GFS, just to give us some perspective before we go to the ensembles. Okay, so right now over the eastern United States, relatively zonal flow. Okay, you don't see mostly west-east motion rather than north-south. Right? Much more pronounced amplified flow here where we have this big cutoff low aloft off of the coast of California. So in this is going to favor quick moving kind of weather systems like the system we might see moving through. We saw that cold front. And I'm going to kind of just let us look at the near weather. Okay? So that's going to be our next chance of precip. We saw that cold front pushing through today. Might be a shower. So the best chance here is this more pronounced cold front with this low kind of moving through. Right? This itself looks like a clipper. If we pass it along further Alberta, moving through into our present weather today and tomorrow. So this is Tuesday. So maybe some light rain showers associated with this cold front for tomorrow. Okay, so behind that cold front, you see the tight packing of the isobars. That's going to mean it might get pretty breezy tomorrow as this cold front passes through. Okay. Is there a chance it could briefly change over to snow? Possible, but probably more likely to be on the rain side of things. Okay. So then moving out further in time, right? That's less of a big weather maker. But if you're looking out west, you see a lot of blue on this map. Okay. So this next major low pressure area is going to be setting up and eventually tracking up toward the lakes. Right? Now that seems pretty far west of a track impact us, but you saw where that front moved through. There's actually this frontal boundary here, and a lot of overrunning precipitation that's going to extend all the way from out in the Midwest over toward Pennsylvania. So if you get warm air being pushed up and older underlying cool air, that's going to be in the place out in the front, right? That's going to be set up for potentially some wintry precipitation, at least north of primarily I-80 or so. So that's what we want to take a closer look at. Let's switch over to the Penn State E-wall to watch this pattern evolve here. Okay, so going out from Tuesday when that front pushes through, right, you can see the vorticity maxima associated with that short wave as the front pushes through on Tuesday. And then we want to step through toward Wednesday, where the weather gets a little more interesting here. Okay, so we saw that cutoff low that was originally off of California, right? By Wednesday is now pushing toward Texas, and then kind of lifting up and heading up toward this low, right? So that huge amplified pattern and that upper level low is going to cause mischief in the Midwest. Okay? And as we get further along, we see here with this area positive vorticity, there's going to be positive vorticity advection ahead of that. That's going to be conducive for developing a surface low. We can see here now kind of an elongated area of low pressure kind of through the Midwest area as we're getting into Wednesday into Thursday. Okay? You can see a tight pressure gradient between here and the high to the north. So if there's any precipitation up here, that could be potentially blizzard conditions. Okay? And then that low is going to probably lift up through the lakes and eventually move on out. Okay? So we don't really see any kind of redevelopment, not much sign of a redevelopment of the low as that flow moves through. Okay, so what are the impacts further down the surface? So for that, I'm going to go to this view of the GFS. And what we can do is actually take a cross section on tropical tidbit site. So we're going to go from, go back to my model a moment here. And what we're going to try to do is actually take a cross section through the warm front where there might be mixed precipitation for us. Okay, so this is 0 UTC Thursday, so this is going to be late in the day on Wednesday. And we can get sounding. So first of all, I'm going to take a model sounding over State College and look at the temperature structure. So you can imagine with overrunning, we have warm air pushing up and over, and we see this warm tongue right in here. Okay, so if there's any snow higher up, it's going to be melting. Depending how deep this layer is, this could be refreezing into sleet or maybe freezing rain at this time. So to get a better view of this, I'm going to now do a cross section. And we can take a look through the front. So seeing some senior students in the room, you've seen potential temperature surfaces before. Okay, so a parcel, as it's moving along kind of from the warm sector, this is point A, up to B in the cold sector, it's going to stay along these isotropes unless, of course, we have some latent heat release, in which case there might be additional vertical motion. Okay, so this air is going to be rising up and over. These lines here are the frontogenesis. So right in here is the heart of our front. You see basically our isotropes packed close together. And these colors here are vertical motion. So right in here, we have some strong vertical motion. And where's that located? Right, that's up here. So I would say northern Pennsylvania, western New York might have the biggest chance for some decent wintry precipitation. Kind of, you have that strong vertical motion along the front, and then that's going to be forming in cool air, and then maybe going through that warm layer, depending on the thermal structure, and refreezing again. So taking another look here is relative humidity and vertical motion. And also right in here, and you can see decent amount of moisture in this layer, and that's also where the strongest vertical motion is kind of located right in here. So if we wanted to get a sense of what type of precipitation this might be, one thing I like to look at is the ensemble plumes. So this is looking at 20 different copies of the GFS, the GEFS, and looking out in time for, first of all, here's our cold front that we saw for Tuesday, slight chance of snow on the backside, but probably mostly rain. Okay, and then here's where that warm front is pushing north and you have the overrunning precip. Okay, so right here, this is freezing rain and sleet showing up as some of the higher probabilities maybe later in the day on a Wednesday. And then once the warm front comes through, it's going to get quite a bit milder. In fact, it might even be in this well into the 60s over parts of Pennsylvania once that warm front pushes through. Okay. So for precipitation type, we could also look at temperature. Right, we can see how that changes. Right? Any wintry precipitation will be rapidly melting here. Right? Temperatures well up into the 60s. And then once the associated cold front moves through, we get back into kind of cooler, more seasonable temperatures for later in the week. So to look more at where the wintry precipitation might be, we can go to the Weather Prediction Center. They have a few different tools we can use. So this is an interesting one. This is probability of different precipitation types across an ensemble. Okay, so this is where the probability of sleet might be. Okay, so we can see this is for 0Z Thursday, so late in the day Wednesday. Right, so State College, slight chance of sleet, probably more of the actions would be more to the north, but all kind of along that frontal boundary, chance of sleet. We can go to freezing rain. So more, you have a cold, deep enough cold layer that we're probably going to be getting more sleet than freezing rain, at least in model space here. Depends how well the model resolves that layer of cold air. And any of the snow, that's more further north, right? Not in Pennsylvania anywhere, right? But probably on the backside of this low through Minnesota, Wisconsin, Michigan, southern Canada, be the best chance for snow. Okay. Another thing to look at, this is the Weather Prediction Center Winter Storm Severity Index. This also gives an area where to be looking at if we want to chase winter. And again, there we see that low is tracking up to the lakes. Right? On the western side of that low, there could be some intense snow, and we definitely saw a bit of wind. So the biggest winter impacts probably through here with this storm. Okay? And of course, earlier out over the mountains. So then we'll step a little further out in time with the GFS. So here we are for Wednesday and Thursday. Okay, we see the big trough over the west. Okay, once that system lifts up and out. Okay, and what's going to the future, we still see it looks like another cutoff low. Right, this winter I've seen just so many tracks of lows up toward the lakes. Not too much happening in the eastern seaboard. And it doesn't seem too much that we're breaking necessarily out of that pattern. One thing to look for in the extended range is to see if we get another shot of cold air toward New England in the extended range. So that's something to look at for the future. To look at the Climate Prediction Center's outlook for kind of going out in time for a week or more. And they have a key message, high risk of intense cold of the northwestern part of the US and potentially northeast. So you can remember that there was a brief, but a very intense Arctic outbreak in early February. That's when Mount Washington got its minus 109 wind chill. So looking further out in time, I'm not necessarily seeing something quite as extreme, but could another piece of the polar vortex be dislodged toward the New England area? Possible, something to look out for. And then just thinking about for the GEFS ensemble plume, we want to just get a taste for the longer range, right behind the storm, relatively cooler conditions, maybe rebounding to more seasonable, and look at precipitation. After our kind of Wednesday, Thursday system, right, relatively quiet until we're getting later in the period. What might that look at? Again, this is a single GFS rather than an ensemble, so we need to take this with a grain of salt. But if we're looking out toward the winter for the weekend, and it looks like more kind of two short waves, one of the northern stream, one of the southern stream, not really phasing that well, so more of a clipper and then kind of a system to the south. And the last few model runs are kind of similar for this. So unfortunately, not a necessarily big coastal development, but right in here, right, finally the system started to get its act together and draw some cold air down behind. So that kind of matches with that potential longer range risk of a colder outbreak focused more on New England. Okay, similar again. And so a lot of kind of similar patterns, this at least over January into February this winter, of tracks up to the lakes, occasional cold air outbreaks, but just not a lot of the classic East Coast winter storms that we're hoping to see, at least from the NASA field campaign point of view. So what's kind of our forecast recap for State College? So today, right, we might get a brief shower, but really the bigger threat is tomorrow as that cold front pushes through. Right? Probably rain showers, slight chance of snow shower, but primarily rain. And then going into Wednesday and the Thursday, later in the day Wednesday, that's when there might be some wintry precipitation. Could start to snow, but probably more sleet freezing rain late in the day, just until that pushes through, changes things over to rain. Then we're kind of in mild conditions briefly, well into the 60s. Cold front pushes through after that, and we're back into seasonal weather. And so probably the biggest period to watch out for in State College is that late Wednesday into Thursday time. So at that point, I will wrap up this discussion of what I have prepared and Anything that you would like to take a look at or any questions?
Maybe a bit early. Do you have any thoughts on possible, like, any sort of cancel closure, like maybe later, say, develop to win the evening?
Yeah, let's take a look at the timing here. So there's 18Z, and pivotal weather actually gives us GFS at every 6 hours. So we can get a sense of maybe the timing of an arrival of precip. Now, the good news is, at least as far as that warm air moving through, anything that does fall, I think, should melt relatively quickly once you're out of that. But then the top key is, does this arrive when campus activities are happening? Okay, so to do that, let's take a look at some models here. Okay, I can zoom in maybe to the northeast. This will work. And then we're going to work our way out. It looks like we have the latest GFS just coming in, but I may need to go back to the 60 to get up far enough in time. Okay, so here's Wednesday at 18. Okay, so just arriving, I remember with overrunning precip, usually you see it on the radar and the models before it's actually reaching the ground. Okay, so if this timing's right, this is definitely more afternoon, so I don't really see a risk in the morning on Wednesday. And then you're getting a little further out in time. This is 21 UTC. And so that's 9 minus 5 hours. So that's going to come as late in the afternoon. So I guess for those that don't want any disruption, the hope is that things arrive late enough not to cause enough disruption. But depending on the risk of icing, right, freezing rain, usually a little more risky than sleet. If it's more of sleet, things might go on as planned. If it's a little more on the freezing rain side, that might call for a little more caution. So definitely if you have late afternoon or evening activities planned, keep an eye on it. Right? It's too early to make a call on something like this, but know that there's at least a chance for disruption at this range. And going through, you can see it's not a long-lived amount of precip. Okay? And then by overnight hours, you're already into that warm sector, so it shouldn't be an issue for the next days coming up. Good question. Any other questions or things you'd like to look at? Marissa?
At the beginning, when you were talking about your field work, you showed a Penn State ensemble.
Yes.
Is that something that is available to everyone, or is that still just, researchers using it?
Yeah, so this is a prototype near real-time run. So unfortunately, it's very computationally expensive, so we aren't running it continuously all the time, but we wanted to say, is it possible if we have a special computing allocation to give this a try and see if we can get something that might be in a range to be operationally useful. So if I have a big amount of computing available all the time, I'd love to run this in the winter, but this is more on a kind of a special case basis. This is the Penn State ENCAP. We have at Penn State our Center for Advanced Data Assimilation and Predictability Techniques. So Professor Yunji Zhang was a big part of kind of getting this up and running. He did support for the precip field campaign over in the summer over Taiwan. And so this is something that we do a lot of research on. Penn State is developing these data simulation systems, usually more retrospective. We have a case we're studying, and then we run this for a previous case when we don't have to have the forecast finished in time to do a forecast. John?
Seems to me that this is a situation where snow could get to the coast in Northern California. That was an incredibly deep 500 millibar low. I know we don't care about California, but if you look at not that one.
The next one?
The next one.
Right here.
I mean,
Yeah.
can you maybe go to Tropical Tidbits and get a sounding along the California coast? Maybe that's a little bit late.
Here?
Yeah. Not Southern California. It doesn't snow in Southern California. Like Eureka?
Okay, so we're right in here or something?
Yeah, something like that.
Let's take a look at the sounding. That's impressive. Very impressive.
For coastal Northern California. Of course, maybe you got to go back in time 12 hours.
There you go. That looks, let's try this one. GFS says it's possible. That's the intense low, and
I mean, if that verifies it snows
right.
along the coast in Northern California.
What's going on with the winds? It's like slowly been northern right?
Yeah, I guess, okay, well, here's our surface low. So I guess it's winds are coming around from this side, and yeah, that's unusual photograph. I wonder what these standard anomalies would look like. There's a tool here from Ensemble Situational Awareness, West. And you see pretty extreme values on here. And you can also maybe get a look at
Do an ensemble precipitation type.
Yeah.
For your Eureka. From that plume diagram,
Yeah.
the GEFS plumes, they probably do Eureka.
Yeah. And you can go over to P-type. Okay, now this is, I guess, if precip occurs.
Yeah, it's conditional.
Right. So then the time period that you're looking at, we can also put up the 3-hour QPF. Okay, it's active during this period. Okay, and then back to the precip type. That would be very interesting if that verified.
I think that's me.
Too bad we can't fly NASA impacts out to the list. Anything else anyone would like to take a look at?
Does that give snow amounts?
Let's see, well, it's giving precip amounts, not snow. I'm curious, I mean, probably not going to show up on the accumulated snow products, but there's other probabilities here. We can go to precip type snow just to see, right in there. At least in the interior, right? The resolution's probably not that good to really zoom in on the coast.
Yeah, zoom in, click the plus button. Yeah.
Probably based on a course model, and so you have to know where you are with the terrain and things like that, but it's interesting. Definitely the coastal ranges of mountains.
And they don't count, it always snows there.
Mm-hmm.
We need it to snow at the coast in California.
Yeah.
That'll teach you.
All right. Anything else to look at for today? Thank you all for the great questions and being an interactive audience.
Thank you, Dr.
Thanks,
Greybush.
Steve.
Glad to see someone's getting snow.
Yeah.